So now a few examples should suffice. Page 369, I'm going to look at number 24. It gives me a logistic equation. So the first thing is to recognize this differential equation as describing a logistic equation. We see the K right there. We see the M right there. The first thing it does is just ask us questions that we can answer directly from the equation without doing anything. So for example, A, the carrying capacity. All right, so A, the carrying capacity is just this number right here. That's M. So the carrying capacity is 700. All right, B, the size of the population when it is growing fastest. So hopefully you've gotten the idea by now that the size of the population when it is growing the fastest is M over 2, which we now know is 350. And then part C, it says the rate at which the population is growing when it is growing the fastest. All right, so we know that that's going to happen when, this is a value for P, all right? So P equals 350 is when we're growing the fastest. So all we have to do is plug that in here. So dP dt at P equals 350 is just 0.0008 times 350 times 700 minus 350. And of course, what you're going to get here is always going to be P over 2 squared. But it's probably not even worth noticing that. We just go on our calculator and do 0.0008 times 350 times 350 again, because that's 700 minus 350, and we get 98. So that is 98, and let's see if they give us any units here. They do not give any units. So the rate of growth is not 98 whatever's per whatever. Oh, actually it does say, it says P is the population, T is measured in years. So whatever, we don't know what animal it is. So 98 individuals of whatever species per year. All right, there you go. That's number 24. Not too mind-boggling, right? So now let's go to number 28. Number 28 weirdly gives you the exact same equation, but it's asking you to do something different. And by the way, I'm going to ask you to do something different. I'm going to change the directions on this right now. I'm not going to post this. I figure, pay attention to the videos, you'll know what I'm asking you to do, because I'm going to ask you something easier than what they do. It says, solve the initial value problem using partial fractions. Blech, not going to do it. That's what we did that very first example with the moose. I'm going to invite you to never do that again. You can if you want, though. I mean, it's kind of fun if you like that kind of thing. Use a graphing utility to generate a slope field for the differential equation to verify the solution conforms to the slope field, okay? You do not need to do that. Yes, it's going to conform to the slope field. Spoiler alert, if you did use technology, and you can, Google Desmos slope field. There's some nifty applications that do it. I'm going to use one for the Euler section we're going to do on Wednesday and Thursday. But your slope field is going to look like this, and your solution is going to look like that, and yes, it conforms to the slope field, all right, if you did it right. So I'm going to skip, we are going to skip, you and I together are going to skip using a graphing utility. All we're going to do is solve the initial value problem. That's all we're going to do. Boom, just that. We're not even going to use partial fractions, because that would mean going back to that whole process of integration that we did before. I don't think there's any utility to going through that again. So what we'll do instead is we'll say this is our equation, and I can see from this equation that I have the M right here, and I have the K right here, and in order to get the A, I use the P of 0. So what I'm going to do is I'm going to write, I could just jump right to, let's do that. I'm going to jump right to putting in P of 0 equals 10, so we'll use that right away as well. All right, and then I will say, so I'm going to put 10 for the P. For the M, I'm going to put 700. My goal here is to solve for K. I'm solving for K. And when I solve for K, then I'll be able to state the equation. That's what solve the differential equation means. It means state the equation. All right, so then I have 1 plus, A is what A is what I'm solving for. I know what the K is. It says it right there. Solving for the A. Yeah, not the K. All right, so I'm going to leave the A there because I don't know what it is. E to the negative, M is 700, K is 0.0008, and we're going to plug in our value of T, which is 0, which means I could have saved all the time of writing that out if I just know that e to the 0 is 1, all right? But, you know, it's all right if you want to write that out. I think it aids with the clarity, but whatever. So that just means that 10 equals 700 over 1 plus a. So that's going to, I'm just going to move my notes. I know what it is, but I don't know what I did with my notes. How did I move that? There we go. Is that it? Yeah, that's it. Okay. Anyway, so yeah, we can do the little switchy thing. So I have 1 plus a equals 700 over 10, and then you could pretty easily get a equals 69. So then what you do is you take this 69 and you could put it in for the a. So we're going to take this 69 and we're going to sub it for the a that we were trying to figure out. So then we will have, copying from this equation, 10 equals 700 over 1 plus 69 e to the, and then maybe I'll just multiply the 700 times the 0.008, right? Multiply this out. It's 0.56, right? So 700 times 0.0008 equals 0.56, because 7 times 8 is 56, and then count the zeros. All right, so we're going to have negative 0.56 t. All right, that's the equation, and the equation, oh. Yeah, I think I want to leave the p. I really want to have copied from this equation up here rather than this equation, right? So then instead of 10, we're going to say p equals the m, which is 700, over 1 plus the a, which we figured out is 69, e to the mk, which we figured out is 0.56 t. Boom. That's our answer. That's all we got to put. I'll just clean it up a little here. There's not anything you can do to simplify it. There you go. That is how you are going to find the equation for a logistic function. Let's see what I gave you for homework. So I gave you these ones, page 369, 23, 25, 29, 33, 41, 44. 23 and 25 are just like that. Number 26 that I did, 24 that I did, super easy. Basically, A, B, and C, read them right off the function. Number 29, please do the same way I did number 28. Don't bother with the partial fractions unless you really want to. You show off a little bit. That's a good thing. It's nice to show off sometimes. Number 33, find the formula for the guppy population. So that's what we just did, right? And then how long will it take the guppy population to be 100? So put 100 for the p, right? So put 100 for the p in your equation. So let's say I wanted to know when there were 100 of whatever these things were, I'd put 100 for p of t and solve for t. So those are the kind of things you're doing for homework. This is the assignment, and that is it.